The main class here is not an object, right? It does not represent an object. Okay, we call this kind of class, like, this is called a client class, right? It just runs code. Okay, so I'm going to write this down. Of course, you can have this replit for yourself later. But the classes that we've been dealing with so far, this main class, it has like a main method. It doesn't really represent anything that's called main, right? You can't, there's nothing in the world that you can, look, there's a main over there, right? A main class simply is just like the code runner class. It just runs code. It has this main method in it, and it executes code, right? But we can make classes in Java that represent objects, right? And if you read, you probably know a little bit what I'm talking about. I'm going to go to my whiteboard, and we're going to talk about it real quick, conceptually, before we go to the code. Okay? So here's how I might define an object in Java. First, I have to maybe talk about what I should call it. And in this case, an example, I hope you guys are all right with this. I'm thinking of like I was thinking about kind of things that would be easy to relate to. And I know this is not everybody's thing, okay? So imagine that we want to make an object that represents like a Seahawks player, okay? And I know you're like, oh, there we go, like with the football analogies again. Well, we could do a different one on the next example, okay? I'll let you guys maybe have some say in that. All right, so maybe I'll call, just for the sake of brevity, I'll call it player, right? So I'm going to make this little model that represents what I want a player to be. Now, what kind of things do players have, right? So first what we should talk about is the properties that they have. All right, let's just come up with a few. What kind of things do players have? Like any football player that you can think of on the Seahawks. Like what does each one of them have that maybe is kind of unique between them? Does anybody want to type in the chat or say out loud? What is it about players that you could tell them apart, I guess? A number. There you go. Good. So they have like a number on their jersey. So maybe they have a jersey number. And I'll store that as like an int, right? And then there's also a name, and there's a lot more stuff as well, right? I would probably store the name as a string. And you can see we would probably go on and on and on, right? We would probably go on and on. Height and weight and position, age, right? College they went to, so many things, right? But for the sake of our first object, let's keep it to just a couple, okay? All right, what kind of let's see if I can make this thematic here with the colors. All right, does anybody know there's like that an object in Java? Let's see if the reading gave this to you guys. An object in Java is like it's a data, right? That represents the properties, and objects also have what? Do you guys know? What else is there? So a player has attributes, but they also have what? I'm going to call it behaviors or abilities. Right? Yeah, very good. Behavior came right into the chat right as I started writing it. Good. So this idea of an object in Java is this combination of data or properties along with behaviors and abilities that go with it, right? So if you think about us, right, as people, that's kind of all we are, right? We have all this data. We have a height and a weight and a name and a home, birth city, all kinds of stuff, right? And then we have things that we can do: walk, run, talk, jog, code, right? So basically those two things combined kind of make an object in Java as well. So let's talk about like things that a football player might be able to do. Uh-oh, I hear screaming children. Thursdays, man. Thursdays are rough around here. Let's come up with two behaviors that we can do. Throw. Okay. All right. And then maybe one more just for fun, like tackle. All right. So essentially this is it. Okay, a player is, for the sake of our example, is something with a number and a name that can throw and that can tackle. Okay, of course we'd want to make this more intense and more robust if we wanted to like really represent a player. There you go. Okay, so there's so much more stuff we could do, but let's go ahead and go back to Replit, and we'll talk about how to make this happen. Okay, so I want you to kind of code along with me, so I will kind of slow down a little bit. Here's what we're going to do. Go over here on the left here, and you're going to add a new file over here. Okay, so if we want to make code that represents an object, it has to be in its own file. Its own separate .java file. Okay, so I'm going to add a file, and I'm going to call this player with a capital P .java. We're naming it with a capital P for the same reasons, you guys, that scanner has a capital S, that random has a capital R, right? All these things, it's a class that represents an object or a template for an object, right? Your class names in Java should always be capitalized, all right? There you go. So now we have, it's just this brand new class, okay? It's like an empty file. So here's what we're going to start with. We could just say class player, right? And typically, I think in the textbook, you guys see one extra word out here, right? In the textbook, I think they show public class player, right? And that's totally fine. We can make this public. That's fine. We'll talk a little bit about these in this unit, this public and modifier pretty soon. But for the sake of Replit, you don't even have to have the word public. It's basically, just for a short explanation of what that word means, it's called an access modifier. This is not part of the lesson today, but basically it shows it shows how accessible this file is to things that are outside of it. Okay, public is like the highest, it's easiest to access. And then there are other access modifiers you could put here, like private and things like that, that make it really hard to access, right? Other files that want to look at it can't look at it, for example, right? So if you just say class player, Replit knows that you want these classes to interact with each other and be able to see each other, so it just like allows them to see each other. So don't worry about the word public so much right now. Okay, so here's where we're gonna kind of get a little bit intense. All right, this is brand new stuff here. All right, so at the top here, at the top of your class, at the top, we define our properties. Okay, so what did we decide again? What is a player made of? A player has a number and a name, right? A number and a name. That's what we're talking about for the for this particular example. All right. So, what kind of ways do we have so far? Right? What ways do we have so far to define an int, for example, for the number at the top here? I want to see how you would write it right now. Type it in the chat. How would you define a number right here? Knowing what you know now, we have a lot to learn today. Okay, so we might have something like this. This is what we have so far. Static int number, right? Something like this, right? So today, you guys, today is the day that we learn finally a little bit about what static means, right? And it's a little bit tough of a nut to crack a little bit. It's going to take a couple days, but little by little, we're all going to get it, okay? Here's the deal. Okay, I'm going to write it down. Importante. If each instance of this class can have a different number, then don't use the word static. Okay, let me see if I can say that more clearly here. I write this down because some people like to look at this replit afterwards. For example, I'm talking about the number for this example. If each instance of this player that I make, I can make a whole bunch of players, 100 different players, right? If their numbers can differ, if it's individual to the specific player, that is not static. We should not use the word static. Okay, so static is a way to describe that nobody differs, right? In other words, there's only one of those things. But if each player has their own number, let me write it down like this. If each player has their own, then it's not static. All right? That's one way we can start to understand what this idea of static means. All right? So I'm going to write it like this, int number. I don't even know what the number is. I would hate to go like this. I would hate to say like 99, right? Because that basically means I'm trying to say that every player has the number 99. Every time I make a player, they're going to be number 99. And I don't want that. I just want to say that they have a number. Every player is going to have a number. And the reason why I don't use the word static is because each player is going to have their own number. It's specific to them, not static. Sometimes it's easier to describe what static means by saying what it's not. Okay, so what am I going to use for the name? Is each player going to have their own name? Yes, they're each going to have their own name, so I would not use the word static. So I'll say string name. All right, so here's the deal now at this point. Okay, so these are essentially the properties. I'm going to delete this and show you what, I'm going to copy this real quick. This is kind of what you would do at the top of your class. You define the properties up here. Okay, properties go first, but I'm going to put this stuff back here. Okay. And of course, in a typical object in Java has lots more properties than just two. All right. Now, what's something if we wanted to do something static? Right? What is kind of not unique to each player? Right? I'm trying to. Sometimes it takes a little bit of creativity to think of an example of a static variable for a football player or a Seahawks player. Right? Think about. Remember, we're imagining that this is a Seahawks player. What kind of things are not unique to each player that there's really actually only one of when it comes to like Seahawks players? The team, I guess. Yeah, exactly. The team that you're on, or the coach maybe. The color and the logo, right? So for example, if I had, imagining that this is actually called Seahawks player for a second, I think it just eventually is going to look kind of lame to have all of that. Like I'll go back to having it be player for a second. But for example, if it's really shared, right? If I said static string coach is Pete Carroll, for example, I think that's the coach of the Seahawks. I don't know if that's how you spell it. But really, now think about it, right? Think about how this is specifically different than the number and the name. There really is only one Pete Carroll, isn't there? It's not like each player has their own Pete Carroll. Was it two L's? Thank you. Okay, thank you. There's really only one Pete Carroll, and that's what this you can think of as the word static. Each instance of your object doesn't have their own. They all share the same one. Right? There's only one Pete Carroll that they all have as a coach. Right? So we can say that it's shared among all instances of the class. Okay, so some people like to think of the word static as it's shared among all instances of the class. Everybody shares it together. We all share Pete Carroll as our coach. I have my own number and my own name. Those are mine. Those are not static. Okay? And the interesting thing about this is this static stuff, you guys. Think about this for a minute. I don't even need to have a Seahawks player. Like imagine it's like a new franchise that just was born into the NFL. And Pete Carroll was hired as the coach. Before there even is a Seahawks player that exists, I still know that the coach is Pete Carroll, even though no players are on the Seahawks yet. Isn't that kind of cool? So this is a really important idea about static as well. A static variable doesn't need even an instance of this object for it to be true, right? Before any Seahawks ever joined the team, imagine they all quit today, right? All of the Seahawks players quit and there's no more Seahawks players, right? There are none. There are no instances of Seahawks player, but I still know that the coach is Pete Carroll, right? All of the numbers and names are gone because no one plays on the team anymore. But the coach still exists, right? Even if there are no players, the coach still exists. So static variables don't rely on an instance of the object to exist, right? Anyway, that's a lot about static. But it's good to kind of differentiate between static variables and non-static variables. Static variables are shared among all instances of the class. Non-static variables, I'll call those instance variables. Each individual instance has their own that's unique to them. Okay. Any questions about that? Comments? We're going to talk about static a lot in the next couple days. Okay. Now we have some behaviors. So some tests that you can make for behaviors is, would I need a player to be able to do this? Does a player need to exist, and do they do it individually, right? Let's see here. Let's look at my whiteboard view. Does a player need to exist in order for it to throw? What do you think? This is my static check here about whether or not I'm going to do static or not static. Yes, a player must exist in order for the player to throw the ball. This is another test that you can do to see if it's static or not, right? If this behavior is a static behavior or a not static behavior. If you need an instance of the object, like if you actually need a real player to do the throwing, then that is not a static situation. It's kind of like the number in the name, right? In order to tell you what number a player has, the player needs to exist. Right? The player needs to be standing there, and I need to be able to see them. They need to exist so I can look at their number. It's not the same as a coach. I could tell you the coach of the Seahawks even if there were no players, right? Right? So that's another thing. So for these behaviors down here, like throw, let's say it's public. Notice I'm going to skip the word static because I'm going to say public void throw, right? And then I'll say, maybe this is what it looks like to throw the ball in Java. There you go. Do you think any NFL quarterback actually does that? As they throw like a long, deep ball? Yay! I would. All right, so notice here, I'm not using the word static because this action is performed by a specific instance of player, right? This is something that a player does. It has to be that player has to exist. It needs to be an instance, and then I could watch them throw, right? And each player kind of does it on their own. It's not like the Pete Carroll situation. Right? Everybody throws a little bit differently, don't they? Okay, so then I could do the same thing for tackle, public void tackle. And maybe it's just like this. There you go. I don't know. So obviously, you guys, our behaviors that we're going to have our objects do are going to be a lot more interesting than system out println one line. Right now, we're just kind of getting the hang of an object is this combination, right? Combination of state and behavior. I'm trying to zoom out. There you go. We have some variables that represent the properties of the object. And then we have some behaviors. Oops, I need to close this off. Behaviors that those instances can perform. Yeah, we're going to go into that in just a minute too. Very good. All right, so before we do anything else, let's actually see if this works. Let's see if we can make a player. Right? So right now, this is actually good enough. We can talk about the Seahawks player class now, and I'm going to go back to just making it a player. By the way, this is really important in Java. The name of your class at the top, do you see it? The name of this class here has to match the name of your file. All right? The name of your class has to match the name of your file. Okay, so if you want what I've done so far, I'm going to paste it in the chat, okay? If you want what I've done so far, you can go look. Oops, that was to every time someone sends me a message. It like defaults to like making it a private message. Okay, so there you go. If you want what I've done so far, there it is. And you can play around with this with me. So here's what I'm going to do. I'm going to go to the main class now, right? This is where, in this main class, this client class, this is where we bring the objects to life. Okay, right now, this player class is essentially a blueprint for what a player is, right? There are no players themselves yet, but we're describing to Java, this is what players are made of. They have numbers and they have names, and they do this kind of stuff. But I haven't actually made a player. This is just describing to Java what I want the player to look like. This is the kind of things I want it to have and be able to do, right? In order to actually make the player in Java, we have to make it like we make anything else. Like this. Who should we make? Russell Wilson? I'll call him RW3. For obvious reasons. Number 3, Russell Wilson. Okay. So, what usually goes next when we make stuff? What word comes next? Every time you want to build an object in Java, we always use the same word here. New. That's right. And then what we're going to do, just like we make a random or anything else, we're just going to leave it like this. All right, so this is now, I'm creating what is called an instance of the object. I'm creating an instance of player. Okay, so we're going to use that terminology a lot. Player itself over here, this is just for a blueprint for what it would look like, what a player is kind of made of. And then when I bring it to life, I actually make RW3 a player. This is called an instance of player. And by the way, there could be a lot of players. I could make multiple players. Okay. So right now, what do you suppose the name of this player is? What do you guys think the name of this player is, and how would I see it? Yeah, exactly. Someone in the chat says, oh, so scanner, array, and randoms, they're all objects. Yes, exactly right. Right? When we make these new scanners and new randoms, essentially we're just using somebody else's template class that they made a long time ago, like in the 90s, right? And we're just instantiating it. We're making it, we're bringing it to life. Exactly. So now we'll be able to make our own custom objects. Right. Very good. That's exactly what we're doing. Right? This is how video games and things are made, right? Imagine you want to make a golem or whatever, right? You just outline what a golem has, its starting health, its abilities, and things like that, right? And you just code it in, right? And your imagination comes to life. Okay. All right, so how do we even see, how can I print what RW3's name is to see what it is? What do you think I can do? Can I system out println something? How can I check to see what RW3's name currently is? I haven't like set the name, but I wonder if it has one. System out.println. What do you think I would write in here to see RW3's name? Would you guys still like me if my hair was like this? Okay. Let's print. Yeah, I wonder what is it going to do if I print this? If I just print the object itself? Who wants to take a guess? If I just print RW3, what's it going to do? We've seen this behavior before. I'm wondering if you guys are going to catch on. What's it going to print? A lot of you guys probably feeling like you're holding onto the back of the jet ski. I think I have a I have a problem with my brackets in here, I think, in my player class. Let's check it out. What have I done? Oh, I have too many curly braces, perhaps. Let's see. No, that's okay. I think I just had an extra curly bracket at the bottom. Now I have no console anymore for some reason, so that's great. I might have to refresh my page. Sorry, guys. So what we're trying to do here is somebody said, why don't we system.out println rw3 and see what that is? Yeah, I was worried about this. It says failed behind my head here. It says failed to connect. Retrying. So Replit did send out an email saying that we're having so much. Okay, thank you. Thanks for doing that. I appreciate it. That message in chat. You guys, I agree. All right. Well, let's see what happens here. Let's see if we're good. So I'm going to print RW3. I still have problems. Let's see. Let's see if we can figure this out live. This is kind of odd because I don't do a lot of programming in Replit. I have another interface that I use. So, who can help me figure out why this is it says it doesn't like throw. Oh! You nailed it. The message that someone just sent to me is exactly right, you guys. Oh, you guys, this is so unfortunate. All right, someone says, look at throw is blue. You guys, that's awesome you guys caught that before me. I probably would have been sitting here forever. Throw is blue, what does that mean? Words that are blue in Java, what does that mean? Yeah. What does blue word in Java mean? It's reserved, like public, void. They're all blue. They're special words in Java. And throw is a special word in Java that we're not going to learn about this year, but throw is something in Java that we can't use it. We have to call it something else, like throw ball. Okay, throw is a special word in Java. We're not allowed to use that for a method name. Interesting. Okay, remember to mute here. Those of you guys who are, don't forget to mute yourself. Okay, here we go. Good, all right. Okay, there you go. Yeah, you can call it whatever you want. I'll call it throw ball. As long as it's not throw and it doesn't show up blue, then we're good. Okay, back to reality here. That was interesting. Now we can go. So back to what we were trying to do before. I might skip that whole part when I upload the video. Now check it out. Printed RW3 and its player at 76ED5528. This look kind of familiar. What does this remind you of? It reminds us of when it's the address kind of thing, right? So yeah, we're basically RW3 is an address card essentially for where to find this player that we're making. So when we print it, we can just look at, that's kind of the computer's address card for where this player is. What if I want to see RW3's name? What do you think I could do? RW3, how do we see things about arrays and things like that? If we're interested in the properties of an array, for example. What do we put here after it? Dot. What if I want to see the name? Dot name, there you go. Good. So this is one way to access this particular property of this instance right here. Now I haven't given this thing a name yet, But I wonder what Java does when I don't give it a name. Is it going to be a problem, an error? We're going to see here. Let's go ahead and print rw3.name. And it says null. Okay, that basically is like the string version of 0, right? Essentially, it's a blank address card. The name has nothing on it. There is no name. It's null. There is no object, right? There is no string. I haven't provided it yet. So one way that we can set this name first, and we're not going to do it like this pretty much ever again, but one way you could do it is you could set the name like this. rw3.name equals Russell Wilson, like this. Okay. Now, some of you who've programmed in JavaScript or in Python, this looks pretty familiar to you guys. You're like, oh yeah, I remember doing this in intro. We did this in Python. You can give values to these properties like so. The difference between Java and other languages is that other languages, you can kind of add properties on the fly and it has no problem with it. But Java, you need to set it over here first, right? In the objects template class. You need to have a spot for it here. You can't just make up new stuff, right? Like I couldn't say rw3.position. I can't make that up on the fly like in other programming languages. Right? Okay. So now if I say rw3.name is Russell Wilson and then I print it, then I get stuff like this. There it is. You can see down here it prints Russell Wilson. There you go. So I could also ask, right? So I can set properties like this. This is not typical, okay? You're not going to see a whole lot of this in big league Java code. This is typically not how you do it. Okay, and some of you already know what I'm talking about. I know who you guys are. This is typically not how we give our objects names. But you can. I just want you to know this mechanic exists. You can access the properties of objects by doing rw3.name and so on, and kind of do it that way. Okay, so we can also ask, we can have our rw3 perform abilities, right? What kind of things can rw3 do? Yeah, you could throw, right? So we can say rw3. What do you think I'm going to say here? Dot. So first, this notation is like this. You name the thing you want, and then you say dot, and then either a behavior or a property that you're interested in, right? rw3 dot throw, for example. And since, oh no, throw ball. Throw ball. Good, and I use the parentheses because this is a method. This is a behavior. rw3 dot throw ball. Good, so now I'm going to see Russell Wilson, and then whatever output that throw ball produces. There it is. At the bottom there. What do you think? I wonder what his number is right now. Anybody want to type a guess into the chat? What if I print his name? I know it's Russell Wilson because I gave him his name. What number is he going to have right now? That's a good guess. Null is a good guess. 0. A couple of guesses coming in for 0. All right, let's check it out. Zero. It's 0. Okay, so some of you are going, okay, that's annoying because string, the name was null, but the number is 0. The reason those are different, you guys, is because string and int are different kinds of data in Java. A string is an object. An int is a primitive, right? So the best Java can do for a default value for an object is null. right? If the address card is blank and it says null, there's nothing on there. For something like an int, which is a primitive, there is no address card, right? So there's no blank address card at all. So 0 is the default value for ints. So the reason why one of them was null and one of them was 0 was because the null had to do with an object and the 0 had to do with a primitive. Exactly, because int instead of string, that's right. Yep. All right, so when we make RW3, if we don't provide a name and a number, it'll default to null and 0, right? And default just means, well, I got nothing else. That's what I have, right? So I can set RW3's name like this, or RW3's number as 3, like so. There he goes. Okay. This is typically not how we do it, but it's going to be good enough for today. I'm trying to think here. Hold on a second. I really want to show you more, but I'm worried about... I'm a little bit worried about overload. This is the first time that I've gotten to this section of the course, this kind of curriculum, this level in the curriculum, where we have to do things kind of at double speed because of the the format that our school has this year. So here's what I'm going to ask you guys to do in the chat, in the participants. I'm sorry, in the reactions. If you're ready, if you want to learn more today, click the go faster. If you don't want to learn any more today, click the go slower. I was worried about this. This is coming in pretty even. Go faster, go slower. No judgment, you guys. Oh my gosh. Okay, that's probably plenty. All right, so I'm seeing even more than half of the class is... Oh gosh, it's like 50-50, you guys. I think at the risk of overloading you guys with too much crazy stuff, I'm going to stop right here and I'm going to change the assignment just a little bit because I expected to show you one more thing, right? I expected to show you one more thing, but I don't think after all that I've talked about, I think maybe this is enough. So let's review what we talked about. Then I'll stop the video after that. And then I'm going to give you a chance to kind of practice this stuff. In order to set anything, I just got a question in the chat. In order to set anything, you need to have the assignment operator somehow. Right? You need to have the assignment operator, the equal sign somehow. If you don't have it, nothing gets set. That's my answer. If you don't have this symbol somehow in it, then nothing will get assigned. Okay. Let's talk about this. Okay, we talked about how objects in Java are combinations of properties and behaviors. And now you'll hear different vocab for that. The textbook might say state and behavior, right? Or state and abilities or things like that. But essentially it's data with methods, okay? Combined into a package. And that combination of data and behavior is called an object, okay? You can see that this is a pretty simple object and that real objects that we're going to code eventually have a lot more properties and a lot more behaviors and they're more complex. Okay, so when we look at it in Java, at the top of the class, we put the properties. Now there's different kinds of properties of players, right? We learned a little bit about this. If these things about the players like the number and the name are kind of unique, each player can have their own. They can differ. If they can differ, then they're not static. That means each player has their own instance of number and name. Even if two players were called Tommy Smith, they would each be Tommy Smith of their own. It's not like they share the same name, right? They're their own Tommy Smith and I'm Tommy Smith, right? We're separate, right? But if they share something, if there's really only one of them, like a coach, for example, then that's a static variable. I don't have my own Pete Carroll and then this other guy has his own Pete Carroll. It's the same Pete Carroll, right? And as a matter of fact, there doesn't even need to be any players existing at all. All of the Seahawks players could disappear off the face of the earth, and there could just be a coaching staff sitting there, and I would still be able to tell you what the coach of a Seahawks player would be, even if there aren't any. Now notice how that's different than the number and the name and the age and the height and everything. If there were no Seahawks players, I would be like, what number of what? Number of which player, right? That's a big difference between stuff that's static and that's not. All right, so the same goes for these behaviors. Very often, the behaviors of your objects are not static. Like a player needs to exist in order for it to be able to throw a ball. A player needs to exist in order for it to tackle, right? And each player does this in their own way, right? Essentially, they do it for the, you know, their existence is required in order for them to behave this way. Okay, so we call this kind of a class. It's like a template for what a player is. And then when we make these players happen, right? We say player, for example, RW3 is a new player. We have created an instance of that player. By the way, we could have made more. We could have made 100 more players. Okay, and then the way you access their properties for now is like this. RW3 dot, and then you say what property you're interested in, and you can set it like so. Now later we're going to find out that this is kind of not a good way to do it, and we'll see why. But you can, okay? This is the things that Java can do. Right? It's good to see this, right? Even though we're going to do it in a better way later. You can access them, you can print them, right? And then if you want your objects, your instances to behave certain ways and do their abilities, you say rw3 dot and then whatever you want. So what I'd like you guys to do, as I stop